What's up everyone? I hope you're all doing good. In this video I'll cover Numpy, Pandas, Matplotlib, Seaborn packages of Python. If you haven't seen my previous videos on Python crash course, you can go ahead and check it out. You do not need to install any software for this. If you do have Anaconda prompt and Jupyter notebook, you can go ahead and use those things for this course. I'm going to be using Google Collab. In this video I'll be using COVID-19 dataset and iris dataset. I also created my GitHub page where you can find all the datasets and the notebooks. If you go to my GitHub page, you can copy the URL and come back to Google Colab. Here you have to go to files, open notebook, and this if you click GitHub, you can type it my GitHub URL, and then if you search for it, it will open up the notebook that I have made for you. Or you can go to uploads, and then from here you can download the notebook and dataset and then upload the notebook alone here. So that's how you can open up my notebook and you can run all the codes for yourself and try it out, try different things. I hope you will like the video. If you like the video, do click the like button, share it with your friends, and let's get started. In this video I'll be using Google Colab, so let me go ahead and open Google Colab. Right here you can see collab.research.google.com. Go ahead and click it. This page will appear. You just have to click on new notebook, and right away you can start programming. It will load and it will give us a notebook like environment. So this is where we can start typing our programs. So print hello world. If you are not using Google Colab and if you are using Anaconda like Anaconda Navigator or Anaconda Prompt or Python or Jupyter Notebook, you can go ahead and watch my first video in which I'll cover how to download Anaconda Navigator and how to install the packages on Anaconda Navigator. Let me go ahead and start typing. So we need to import Pandas, Numpy and all those things into our notebook. So we just have to type import Numpy as np. We'll cover Numpy first. So import Numpy as np and run this cell. If it is not giving you any error, you are good to go. If you type np dot underscore version, you can see the version that it has, the version of Numpy. We can if you guys are using Jupyter Notebook, you have to install Numpy with this command in your command prompt. In here I can hit shift enter and we can see that the requirements are already satisfied and Numpy is already installed. So let's get started with Numpy. I'm going to create a matrix A of array. Let's say 1, 2, 3. I want it to be in 2 dimension, 3, 7, 5, and we can go ahead and print our matrix. So we have a matrix of shape 2, 3. So if we print a dot shape, it's going to print 2, 3. So we have created a matrix using Numpy np, and we can go ahead and see what is the dimension of this. This is, as I told, it's a 2 dimension, so this should give us 2. A dot dim ndim, so this will give us number of dimensions. It is 2-dimensional array. We can also see the d type of this data type of our array. It is a data type of int64. If you guys want to change the data type, you can go ahead and specify the data type. Type equal to int 32. Okay, let's go for float 32, and it will create a array of type float 32, and even if we print a, we are going to see a decimal point with it. Let's go ahead and see what all we can do in this. We can go ahead and see how many bytes of space this takes. A dot n bytes. This will give us the bytes that it takes. Let's create another array. B is equal to np dot array, and let's make it a little bit bigger array. Let's see, we want to make an array of this shape. So now if you print b, we have an array of 2, 5. Let's go ahead and extract individual elements of the array. Let's say we want only the first row of the array. We are going to print b, and then inside square brackets we are going to specify 0. This means this element right here is considered 0, and then this is considered as 1. That's how indexing works in Python and Numpy. If you want to learn more about indexing, go check out my previous video in which I have covered list under list. I have taught about how indexing works. By the way, if you have more doubts, you can refer the notebooks given in the description below. So if I want only specific element, like let's say I want 2 of this. 2 is an index 0, 1, 2. So if I give 2 right here, it is going to give me 2 only. Let's say I want to get 7 of this. I just have to specify 3 and it will get me 7. So this is how you can get individual elements of an array. We can also specify this with 0, 3, and it will print the same thing. Similarly, we can get specific row. Let's say b, and then in square brackets I want everything in the first row, and I want everything in that. We can also do this, or if you leave it as blank, also it will give you everything. Let's go ahead and do something like this. Yeah, it is going to give us a 0 array. Okay, that's cool. Let's go ahead and specify the start and end index. So okay, let me copy this. So we can specify the start index, the end index, and step size. So start index is 0. In this I'm starting from 0 and I want entire thing. In this I'm starting from index 1 and I want till 6. 6 is this element right here. So 0 means this entire array, and inside this array I want elements from 1 to 6. So we are skipping the element 0, index 0, and then we are taking the element from 4 to 9, and then I want every second step of this element. So we start at 4, we skip one step, and then we take the second step element, that is 7, and then we skip number 4, and then we take the second step again. So this should give us 4, 7, and 9. Let's go ahead and run it. Yeah, we get 4, 7, 9. We can also specify till which point you need. So we are taking from first to fifth element. So first to fifth element, and we are jumping one step every time. So this will give us 4, 7, 4, and then 7, 4, 7. Let me create a bigger array. I'm going to copy a 3D array. So this is a 3D array. This is 3-dimensional array. And if you go ahead and run this, and if I print this will give you a better idea of how a 3D array looks like. So we have two individual matrices. This matrix right in the top is a 3 by 4 matrix, and again another matrix, and it is enclosed in a bigger array. So this is an example of 3-dimensional array. 3-dimensional array is particularly useful in working with RGB images. So RGB images are stored as 3-dimensional array, and the x-axis represents the width The y-axis represents the height, and the z-axis are the color channels, that is red, blue and green, and each individual elements represents the intensity of red or blue or green. So let's go ahead and get a specific element of C. Let me type C, and if I want to get the specific element of C, we have to work from inside out. I'll give you an example of how it works. Let's say I am typing 1 comma 0 comma 1 comma 2. So 0 means this matrix right here, and then 1 means this is 0, this is 1. In this I want the second element, second index. This is 0 in 2 is 0 index. This is index number 1. This is second index of that element, and I can hit enter and I can get 3. So this is how you can index a 3-dimensional array. We can go ahead and replace an individual element. We can say C of, let me copy the thing from the top, and I want to change it to, from 3 I want to change it to 33, and then let's see how this, whether C is changed. As you guys can see, in that index position we have changed. So arrays are mutable. Numpy arrays are mutable. They can be changed into any format. But if I go ahead and type a, if I place a string in this, it will throw me an error. As you guys can see, it is throwing me an error saying that it expects only integers, because we have specified that this is an integer. The data type of this array is integer. So why is array so important for us? Why we are not using nested list like we saw in the first video? Nested list will take up a lot of space because every element has to have an address. They have to have a data type, so it takes a lot of space in our system. If we use arrays, this will be organized. The first element will have an address of, let's say it's having an address ending with 007. The second element will have an address 008. The third element will have an address 009, and so on. So it is continuous. So we just have to save the first element's address to access all the other elements. So it takes less space. And one more thing about numpy arrays, we are specifying that it is a type int 64 or int 32. So 32 represents the number of bits, the number of zeros, that it basically means how less of a space you can take. But if we are specifying, if we are doing it in a list, it takes up a lot of space, because a list can contain strings, a list can contain numbers, a list can also contain floats. But in an array like numpy array, it can only contain one data type. So the data type is specified for the array, not for the element. In list, every element will have a data type stored in them. So this is much more efficient to run. Let me go ahead and talk about how you can make your own array without typing codes, typing the entire array. So there are things like np.zeros. So this basically takes a shape, and then it is going to, we have to specify the shape inside bracket. So if I give 5 comma 5, this is the shape that we want our matrix to be, and it has to be filled with zeros. And if we hit shift enter, or if you run the cell, you get a matrix filled with all zeros, and it is of shape 5 comma 5. If you don't have 5 comma 5, let's say you just enter 5, it's going to be a single line array. It's going to be one-dimensional array. You can specify the shape of this to be 5 comma 5, and we can also specify other things like data type, d type. So we want our d type equal to, let's say we want this to be an integer, not float. We want it to be int 32. So now we have a array of integers 0, and we can go ahead and create np.ones in the same fashion. This will make a matrix containing all ones. Similarly, we have something called full. And what this does is it takes in two parameters. It takes the shape and it takes what it has to fill in. So if we specify 99, the matrix 3 comma 3 is filled with 99. Everything in this matrix is filled with 99. Every element is filled with 99. And we can also specify what data type it should be, whether it should be float or int or anything. So this is also very useful. Let's go ahead and make a matrix, make a fill matrix, but we want this shape to be equal to some other matrix. So let's go ahead and see that this is equal to C. So we are storing this matrix into a variable C. And if I go and use np dot full underscore like, and I can specify which matrix which matrix shape I want. So I'm going to say that I want shape of C matrix, and then we are going to specify fill value. Fill value I want it to be 44, and let's go ahead and print it. Now here you can see that it is filled exactly same like how C is. So we have 44, every element is 44, but we take the shape of C matrix. Yep, it's 5 comma 5, but we take every element, we make every element to be a 4 comma 44. Next we have random. So we have np dot random dot, and here you can see all the options. We have rand int, and other stuff. So we can use rand. What rand will do is it will give an, we just need to specify shape. Let me go ahead and specify shape of this matrix. So what this will do is it will make all the numbers to lie between 0 and 1. These numbers will be created randomly. So every time you run this cell, you get different values. It tosses up a random value into this matrix. So this is what a random does. We can go ahead and we can also specify rand int. I want to change the shape of this to 2 comma 4, and it's also going to ask us the maximum and minimum. We shouldn't forget to give the maximum. I want minimum of 0. I want maximum of 10. Maximum value inside the matrix should be 10, and then we specify the shape. So we have low, high, size. So size is 2 comma 4, low is 0, high is none. And let me go ahead and run this cell. You guys can see it randomly generates numbers between 0 and 10 in the form of 2 comma 4 matrix. So if I run this again, the elements inside it will change. Let's go ahead and make an identity matrix. np dot identity, and I want the matrix to be, it can be only square matrix. So identity matrix is also called a square matrix. So identity matrix, it will fill the diagonal elements from top to bottom to 1, and then you can go ahead and store this as, let's say you want to store it as A, and then now we have a matrix A that has an, we can go ahead and also multiply this with any number we want. So now we have a matrix in which the diagonals are 5, and similarly you can do matrix multiplication, division, anything to this. That is the beauty of Numpy. It's so simple to use. And let me go ahead and make a new array. We are making a new array called ARR, and we are storing 1 comma 2 comma 3 inside this array. We are going to make another array called r1. We are using np.repeat. So what this repeat does is it takes an array and then it repeats it to here. I am giving it has to be repeated 3 times, and in which axis it has to repeat. So 0 means y axis and x means 1 means x axis. So that's how I keep it in mind. It's up to your choice whether you keep it as row, columns, etc. So now if we print r1, it is going to contain 1 2 3 1 2 3 1 2 3. So it has been repeated 3 times in the axis 0 in the y direction. Let's go ahead and make something useful out of what we have learned. We are going to make an output of np dot ones. Let's say that it has to be a 5 comma 5 matrix. Let's print the output. Let's make another matrix of np dot zeros, and we want this to be 3 comma 3. Let's also print this z. We are going to leave a space. Let's go ahead and print this too. So now we have a matrix of all ones in the shape 5 comma 5. We have a 3 comma 3 matrix filled with zeros. Here what we can do is we can specify an index 1 comma 1 1 comma 1, and then we can set it to 9. When we print this, see the center element has been changed to 9. I'm going to leave a line here that is specified by \n, and we are going to I need this matrix, second matrix that I made, that is z. Inside of this matrix I want something like this. I hope you guys can understand. So here we are going to specify which is a starting point and ending point. So we have 1:4 and 1:4 again, that is equal to z. So we are taking this z and then we are putting it in this place. So this is everything that we have learned in the top: indexing, slicing and all. So all this 1:4 and 1:4, what does this do in here? So this 1 and this 1 specifies this place. This is the index for this blue marked area. This 4 and this 4 indicates this place right here. We can also use -1, so that also indicates this place only. -1. You have to check out my previous video of list if you want to understand why we are using negative in this place. But to keep things simple, I'm going to use 1:4 and 1:4, and then we are going to take this z and then we are going to throw it in here in this place. And then if we print output, so we have all the 4 sides filled with ones, and then we have zeros here, and then the center element is 9. So this is how you can make a matrix that you like. So if let's say you have a picture, you want to make borders, these ones will represent borders, zeros will represent white color, one will represent black color, and zeros will represent white color. Similarly, all the numbers will lie between 0 to 1 in a grayscale image. So we'll talk about it in image processing video. Let's go ahead and finish off this with some more examples and some important things to notice. Let's say that I'm creating an array of a equal to np.array 1 to 3. I want to copy this to b. Okay, so be careful when copying array. I want to copy this array a. This contains 1, 2 and 3 into b, and then I'm going to change only b, first element of b, to 99, and if I print a, it changes the a also. So what this does is it doesn't copy the array, it copies the address. So in order to copy an array, you have to use np.copy. So let's go and type b equal to a.copy, and what this will do is if you print b now, we have already changed a to a of 0 to 99, so we should expect the same thing. So we have 99, 2 and 3. Let me go ahead and change a of, I am changing the a of 0 to b, let's say 77, and if I print b, the b stays the same, only the a changes. If I print a, it's changed to 77 as we specified. So you have to be careful when copying. You have to use a.copy. You have to use this dot copy method. So I'll just give a very brief idea of this. We are making a matrix A. We are copying this B equal to a dot copy. We are copying this matrix into B, and then we are changing B of first index. So this one in B, we are changing it to 100. Now we are printing A comma B. So now you can see that the A stays the same. The B, in which I changed it to 100, changes. So this is how you have to copy the array. Let us go and start with some mathematical operations. We already assigned a. Let's say that you want a plus 2. All the elements of a will be added with 2, and same way you can do a minus 2. You can store these values to z equal to a plus 2 and do other things. You can also multiply, divide a star 2. This will multiply all the elements of matrix. You can also take sign of this, so np dot sign, and pass in the matrix that you want to get the sign for. This will give you the sign of 1 and 2 and 3. And let's go to linear algebra. We have matrix multiplication, so we already created. Let's go ahead and create a two new matrices. I'll just copy this and paste it right on my notebook. So we have a matrix containing 1s. We have a B matrix containing 2s. This is of shape 2, 3, and this is of shape 3, 2. So this should be able to multiply with each other. And then we use np.matmul. Matmul means matrix multiplication of A and B. If I go ahead and run this, we get a matrix multiplication. We do a matrix multiplication and we get 6. So this is simply how you can do matrix multiplication using Numpy. Now if you have a wrong shape, I'm changing the shape here from 2, 3 to 3, 3. And if we do matrix multiplication now, let's give it a wrong size. Now we get a error saying that size 3 is different from 4. So you can get different error in different versions of Matplotlib, but you have a error saying that the dimensions are mismatched. So if you find this, go ahead and check whether your dimensions are correct or if there is something buggy about your dimensions. Now you get the matrix back properly. Even if I give 3,2, it should be good. Let me go ahead and do some more things. So we can find the determinants of any matrix. First, let me create a matrix, identity matrix. So in that way, we know the answer easily. Dot LINALG. This LINALG means linear algebra, and determinant of A. And if I print, it should give me answer as well. So we are creating an identity matrix here. You already know what is an identity matrix. So this is how it looks. It's filled with ones from on its diagonal, and if you take the determinant of this, it's going to give you the exact same answer as this. It is going to be 1 minus 1 plus 1. So that is the answer for this. You can of course pass in any matrix you want. For that, let's take B, which is filled with 2's. I'm going to copy this line, np dot linear algebra dot determinant, and then we are passing in B. Okay, for determinant we need a matrix to be square matrix. So you cannot use a matrix that is not a square matrix. Let's go ahead and create a square matrix, and we get the answer right away. Let's go ahead and okay, we can use the same matrix E. So let's type E dot min max np dot min, and this should give the minimum value of we have to pass E, and this should give the minimum value of E. Similarly we can type max, and if we specify which matrix you want to check, then we get 4. So in this matrix we have the minimum value as 1 and maximum value as 4. We can also do E dot min. I think this will work. Yeah, it works. So we have E dot min, and we can type E dot max. We can also do E dot sum, and it's going to add 1 plus 2 plus 3 plus 4. That's 10. We can also add this vertically or horizontally by specifying the axis equal to 1. So we have 3 comma 4. So axis equal to 1 means it is going to add these two elements 1 and 2, and then it's going to add 3 and 4. If we specify axis as 0 in y direction, axis 0 means y direction, axis we have 5 comma 5, we have 1 plus 4, we have 2 plus 3, so that's 5 comma 5. We have the exact same thing. This can also be done. You can type np dot sum, and then you can type which matrix you want to take in, and then you can take the axis equal to, and then you can specify axis as 0. So these two methods are the same. It's up to you on how to do this. Let's go ahead and see dot reshape method. So I'm going to quickly create a array here called having these elements. Let me print a space in between them for better understanding. So we create a array filled with 1 2 3 8 4 5 6 7 of shape 2 comma 4. So before dot shape means it prints the shape of this matrix. So we have an array like this. We want to reshape this to some other shape. Let's say after equal to before dot reshape is a function that allows you to change the shape. And what this does, let's go ahead and run this. So it has changed from shape of 2, 4 to 4, 2. You can go ahead and check after dot shape. We can see that it has changed from 2, 4 to 4, 2. We can also use -1 here. This -1 is going to make it into a 3-dimensional array, and if I hit enter now, it is going to have a third dimension into it. This will be more clear when we are in the machine learning course. For now, you just have to think of this as an empty matrix created, and then the elements are pushed inside the empty matrix. That is what this -1 represents. But if you have a 3-channel matrix, you can, and if you want to convert it to a 2-channel matrix, you can do that. Of course, you can also take a 2-channel matrix and convert it into a 3-channel matrix. This will okay. So we have a 3-channel matrix right now, a 3-dimensional matrix. This last two indicates that this one, the second two indicates this thing right here. This one indicates that it should have 2 elements. Okay, let's go ahead and talk about stacking. We have various number of stackings. Let me make it quick. We have a array v1, we have a array v2, and then we are going to vertically stack it using v stack. And if I run this, you can see that these two arrays are vertically stacked. You can also use h stack. It will combine both the arrays. It is going to combine something like this. And we can just use stack, and then we can specify x is equal to 1. We are stacking in x direction now. So we take 1 and then we take 5. So we take first element, and then we stack it in x direction. You can specify 0, and you can see something like vertical stacking. So that is about stacking. Let's go ahead and talk about how we can change the type of an array. Let's make this as just b, and let's run this again. And if we take a look at v dot d type, it's going to say that it is a d type of integer 64 bit. And then if you want to change this to something else, v equal to v dot as type, and then I can say int 32. And now if I just print v, we can see that the d type is changed to integer 32. And then you can also do something. You can also use Boolean operators in this. Let's say v equal to 6, and if you hit run, so you can see that all the elements are false except wherever the 6 is present. Let's also go ahead and see all the elements that is greater than 6. We have 2 elements that is greater than 6. We can also use less than. These are just Boolean operations. We have 5 elements that are less than 6. Let's go ahead and talk about line space. This is interesting. So we want to create a array, a single dimensional array starting from 0 ending with 9, and we need to break them into 10 pieces. So 10, you can think about it as number of elements, and then we specify the d type. And if you run this, you can see that the numbers from 0 to 9, they are broken into 10 pieces starting from 0 to 9. You can also change this to 19 and run this. You can see that it starts from 0 and ends at 19, but now you are splitting it into 10 pieces, so we have 0 and then 2. Similarly, you can specify, you can even get float. Now we have something starting from 0 until 9, but we broke it into smaller pieces, so we get 0.43, 0.94, 1.42, etc. Let me go ahead and create this into 21 and see. Okay, we have a much neater float values here. So this is how line space works. You can also go ahead and reshape this. Let me convert this into a variable and let's see how this goes. We have, let me print a dot shape to get an idea of what shape it is. So we have a shape 21. We don't want 21, we just need 20, sorry, 20, and then we have the shape of 20. So I can go ahead and type a dot reshape, and then we have to specify the shape. So if I am having 20 elements, I can make it into a 10,2 matrix, right? Yeah, here we go. Here we are having a 10,2 matrix, or I can even make it into a 5,4 matrix. Now we have a 5,4 matrix. You can store this into a new variable, like say it's going to be z. And then if you see this shape of z, if you take a look at z, it's going to be much different than a. So you can take a linear array and you can reshape it into a multi-dimensional or two-dimensional array. You can also make it into a three-dimensional array. Let's go ahead and do that right now. I don't want to go for something very fancy. Yeah, let's just do it with -1. I won't have any error. So now you can see that it is a three-dimensional array, but the third dimension is just empty. Let's go ahead and print z. So now you can see that it is a three-dimensional array. Let's go on to the next topic. You can specify, yeah, this is also something cool. You can specify x equal to 3 and y equal to 5, and then now you can make an array out of it, like np dot array p dot ones, yeah, ones, and then we can go ahead and give it a shape of x comma y. So if you want to create something that has the same shape of x comma y, you can use something like this. So I think that's about it for Numpy. And one more thing, I think this is going to be pretty useful for those who like math. So here we are creating x. X is going to be starting from 0 and it's going to end at 9, and it's going to be split as 10 divisions. So it's going to be 0, 1, 2, 3 until 9. It is going to be a type of int 32, and we are going to create y equal to x square plus 2. So y is a new variable, that is x comma x square plus 2, and we can go ahead, we can print this. You guys can see how it looks like. So we have x and we have y. We can go ahead and stack these two things. We can do np dot b stack, and we can stack x comma y. Let's go ahead and see what is the problem with this. Yeah, it has to be specified inside a square bracket. Now we have stacked this array in this form. So I think that's it about NumPy. Let's go and learn more with Python. Let's go and learn Matplotlib. Let's go and learn Pandas. I discussed below. The notes are in the description if you guys want to check it out. Let's go ahead and import Pandas. Import Pandas as pd, and you should run this command. If you're using Anaconda prompt or Jupyter notebook, you have to install Pandas using pip install Pandas in your command line, in your command prompt. I'm going to show you guys one more time. Anaconda prompt right here, and then you have to run this pip install Pandas first before you import Pandas. Now we have successfully imported Pandas without any error. I'm going to go ahead and get our data. So right here I'm having two data sets. One is a COVID-19 India dataset and another one is a iris dataset. Click on the files on the left side, file bar on the left side. Go to your directory where you have your files saved. Just drag this file and drop it over here. This will give you a reminder that it will get deleted when runtime is recycled. Click OK, and same like that, get your other file, the iris dataset, and drop it in here. Let's go ahead and take a look at our dataset using Pandas. Let's make a variable called data frame df. You can name this anything you want. I'm going to name it as df, and we want to read this file. So pd.read underscore, you have lots and lot of options. We have clipboard, CSV, Excel, Feather, HTML, JSON, Pickle, etc. This file is CSV file. It is having .csv extension. So we write .csv, open and close bracket, and then we have to type in the file name. It is COVID underscore 19 underscore India.csv, and let's see the top 5 objects of this dataset. I'm going to go ahead and hide this. We can see that it contains serial number, the date, time, state, union, territory, confirmed Indian national and confirmed foreign national, cured, death, and confirmed. If you want to take out the entire dataset, you can just type df. It is going to show you the top 5 and the bottom 5. In between values will not be seen. There are methods to see the entire dataset, but on a large dataset like this, you don't want everything to be shown, since it will hang. It will be very slow on your system. So we have a data frame like this. You can open a CSV file and you can view it like that. Also you can also view through pandas through Python like this. Same like that, you can give df.tail and it should give you the bottom 5 elements. If you specify that you want 10 elements inside these brackets, it will show 10 rows. You can also make this into head and see the top 10 rows. Here you can see top 10 rows. Let's go ahead and start with data pre-processing. You can go ahead and type df.describe. If you hit shift enter, it's going to show you the serial number, queued, date and confirmed. It is going to give you a count, mean, standard, minimum 25%, 50%, 75% maximum. So this will be very useful. We can see that the maximum queued is going to be this many values. We can see confirmed around 4 lakh or 400,000. We can see that we have a maximum of around 14,000 deaths on a single day. So this will describe it in this way, but this is pretty hard to understand. So we can type transpose, and now you can get a clear idea of what is going on in your data. You get serial number, queued, depth and confirm, count, mean, standard, then max, all these things. Okay, why are we not getting this confirmed foreign national and confirmed Indian national? Because these data are missing. I am going to show you guys that only the top part is there. The bottom part is not present. These data are missing. Missing in the sense these data are filled with minus sign rather than just being a none type. So none type is when you leave the data without any elements in that. In this they have given an symbol like this, so it is not a none type. Let us go and also type df.info, and this is going to show that we do not have any none types. So we have 404,671 rows. In all the 4,671 rows we do not have anything missing. All serial number, all data, date, time, state and union territory, queued, depth, everything is filled, but we do have some missing data as just these symbols, this negative sign symbols. Let's go ahead and also use another method to find the number of null variables. So if you go ahead and type df.snull, we get false, 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 false. If you want to count this, you can just type dot count and it will tell you the number of non-null elements. So you can see that it is all 4,671 and hence we have all the elements filled. We do not have any none characters, but we don't have data for confirmed Indian nation and confirmed foreign nation. After a while it's just filled with negative symbols. So I got this data set from Kaggle, but I will leave the GitHub page where you can download this dataset. And let's go ahead and talk about indexing. So this is df dot index location. ILOC is index location. We are taking the third element. Before this, let me insert another dot. Let's print our data frame. This is our data frame. And this I'm going to take this number third. I need this to be separated. I need this data alone. So I'm going to say that at index 3, and if we print this, we get serial number 4, we get this date, and we get this data exactly right. We can also specify one more variable. Let's say I want 3, 3. I want this element. You can specify using the index like this, and you can see that we got this element that I was telling about. So this is index location. Using index of the data, you can get individual elements. We can go ahead and use LOC. LO is location. df dot LOC. Now we need df in our data frame. Check for state union territory. State union territory equal to I want only Tamil Nadu dataset. So what this does is, this will, let's take this one. So this will check if the state union territory is Tamil Nadu, and it will filter all the data which is having only Tamil Nadu as state union territory. And then this df.loc, it will look, this is location. LOC, look into only these files. Let me just run this and you can get an idea of. So we have separated the dataset which contains only the state Tamil Nadu. I hope this is pretty clear. We just need to specify that state union territory is, we want this to be, this will be true, and it will look into only these true values. So this is how you can use df.lock. We can also sort values. So we are back into df, this large data frame. We just used this to look into only Tamil Nadu dataset. We didn't save it. We didn't save it like, if you want to save this as some other data equal to, you can save something like this, but we are not going to save it. Let's go ahead and sort our data according to the number of deaths. So here we have 0 deaths and it is increasing. If you go ahead and ascending equal to false, this is going to make it into a descending order. So we have the maximum death at the top, and then it decreases. We can also sort by 2 variables. So here we want both deaths and cure to be ascending, that is starting from 0 and continuously increasing to maximum. I want maximum death and minimum cured in a day. You can do something like this. So we had in the last row we have maximum death and minimum cured. That's what this represents. So you can also change it to something like this, and now we have maximum death. You have ascending of death as false, so we have maximum deaths and minimum cured. So this is how this works. And then we can also delete the columns like this. So here we are dropping df.drop this confirmed Indian nation. We don't want this confirmed Indian nation national, and then we are dropping it along y-axis. I told you guys that this axis equal to y means along y-axis. So if you change this to 0, I'm pretty sure that it will throw an error saying that the axis is not found. So you have to specify the correct axis, and then now you can see that we have dropped confirmed Indian national. We just have confirmed foreign national and cured death and confirmed. We can drop even multiple columns. We can also drop this using this. So here df.drop, and then we are specifying that I need the columns to be dropped, and then we are passing in two columns, confirmed Indian national and confirmed foreign national. Using this, we are dropping both confirmed foreign national and confirmed Indian national. If I run this, you guys can see that both of them are dropped, and we can also save this into a data frame. So df equal to df dot. Let's go ahead and print this. And one more thing to keep in mind is once you run this cell, you're not supposed to run it again. If you run it again, it is going to give you an error saying that keyword error. It couldn't find these two elements are not found because we already dropped it. So this is something that you have to keep in mind. Let me go and import the dataset again, and if you come back here, we should be able to run this cell easily without any problem. And if I print df here, you can see that we have a new data frame in which we don't have confirmed Indian national and confirmed foreign national. So if you specify some unknown parameters like this, columns equal to unknown, it is going to throw an error similarly, same like how we saw. See, unknown not found in axis. So this is an error that you'll get. And also you have to keep in mind this confirmed Indian national, confirmed foreign national, the state, union, territory, everything has to be exactly right. If you even make a small spelling mistake, like if you forget to capitalize the C or capitalize the F, it's going to give you an error that it is not found. So please keep that in mind, and then make sure that you guys are uh, you guys can simply copy using Ctrl C and paste it in here. In that way you won't make the mistake. So let's go ahead and continue with the section. So we can separate state, union, territory alone. We need to know the elements of state, union, territory. If I run this cell, it's going to show that it contains 4670 elements starting from Kerala, and then we have many elements. So I just want the unique elements of this. So we have now unique elements. We can also count the number of unique elements by just giving n dot unique. It says that we have 42 number of states slash union territory, because we have Telangana three times here. So it's not a perfect data set, but it will do the job. So as I told you, if you want to separate our data, so in this we can see that we are taking state, union, territory equal to Tamil Nadu. It is enclosed within a parenthesis, within a brackets, curved brackets, and then we have a OR statement. This is OR statement in Pandas. You can find this on top of your forward slash. If you press shift and then hit your forward slash, this should appear in most of the keyboard. So this is OR in Pandas, and then we have another check to check if the state is state, union, territory is Telangana. So now we have two states in a data frame called South data frame, and we are separating it using df.loc. Now we can print the elements. Let's get rid of the head so you can see more. So we have Tamil Telangana, and this is how you can split your data. You can add even more uh, elements to this, same like this. You can add more or statement. Okay, and to simplify things, I need only state union territory as Tamil Nadu. So I'm taking this, and then I want to change every Tamil Nadu into TN. I want to simplify this into just abbreviations. So what I can do here is I can simply type tn underscore df dot loc, and then as usual we open and close square bracket tn underscore df. We need only state union territory. We check state union territory to be equal to Tamil Nadu. I'm gonna copy this, Control C, and then again paste it right over here. So if it is Tamil Nadu, then I want to change every time this Tamil Nadu appears in state union territory. That one I have to change it to TN. And if I take a look at my data set now, we might have to, let's check if everything is right. Let me go ahead and type tn df equal to okay. Here is the mistake. We have 2 equal to sign. We are going to assign tn. So this is a true or false statement. So we use double equal. Here we have to use single equal sign. So let's go ahead and run this. You can see that it has been changed. All the Tamil Nadu elements is changed to tn. It will give you a warning saying that you're changing the data frame itself. That's what we are trying to do, so it doesn't matter. Let's go ahead and get the columns individual. So we need this SI number, date, time, state union territory, keyword, death, and confirm. So we are typing tndf dot columns, and then we are going to use values to extract the values. Let me go ahead and show you guys what each piece of this does. Okay, so this gives you an array, and it also gives you the d type. So we don't want this d type, we just need these elements, the s number, date, time, state union territory, etc. So we specify that we need only values and not d type, etc. So that's what this value does. And then we are going to cast it inside a list. So whatever this may be, we are going to cast it inside a list, and then we are going to store that list as columns. And if I print this, see, we get a list with serial number, date, time, state unit territory, keyword, death, and confirmed. What if you want to change this columns? So there's a command you can use. You can simply use dot columns, and then you can specify what the columns should be. So if you're using this, you have to specify the from the first column till the last column. Even if you want to have the same yes number, you have to have it inside this. I wanted to make them all small letters, and also I want to make the state union territory to just date and confirmed to just conf. So running this, let's print it out. So now you can see that the headings of the columns have been changed. Alternatively, there is also another method. You can do dot rename. So here I have changed it into conf. I have to convert it back to confirmed, but with small letter c. And then I want the yes number to yes underscore number. So if we can specify what you want to change, and then you can also specify the element that you want to change, like the heading you want the conf to be changed to confirmed, yes number, and to be changed to yes underscore number. So this is also a method you can use to change or to rename individual elements of column. If you take a look at it now, you guys can see yes underscore number, previously it was yes number, and confirmed, previously it was conf. Yep. Now if you want to change the order of these columns, if you want, let's say if you want state union territory to be before time and you want the time to go to the last, you can do indexing. You can do slicing and indexing. It looks something like this. So we say that tf underscore df, the columns starts from 0 and stops with 2. So we have till date, and then we want column starting from 3. We don't want time, we are not taking time, we want state, and then till second last, that is death, and then we need time. So we specify calls 2 apostrophe 3, and so we have time. So this is 0 element, this is index 1, this is index 2, and this is 3. So if we specify 2 is to 3, then it will take only number 2, it won't take the 3. This also I have previously mentioned in when doing list. So if we run this, you can see that obviously the time has come to the last, the state has come in forward. So I think we didn't actually change the state union territory properly. Here we should have saved it into another data frame. So anyways, you get the idea. Let's go ahead and read our data frame again. Let's start fresh. Df equal to pd dot data read csv, and then specify the name of the data, run this. If you get no error, you are fine. If you are trying to access a file that is not available in your folders, in your files, it will give you an error. If you have even a small spelling mistake, it will give you an error. So that's something that you have to keep in mind. Let us go ahead and see how our data looks like. Let's also talk about group by. So we can group this data using group by. I want to group by deaths, and if I run this, now we have grouped it by deaths. So here you can see, guys, we have 0 deaths, and then it shows serial number. We are going to sum up uh, all the things. We have 0 deaths, and we are going to sum all the elements of 0 deaths, and then we have 1 death. So wherever we have 1 death, it is all going to be summed, and we are going to get a serial number unqueued and confirmed. We cannot sum strings, time or date, so we don't have those things in this. We can also use this like so. So here we are going to group by state union territory, and then we are going to take a mean and then sort values by deaths, ascending equal to false. So running this, we get all the state union territory, and then we take the mean of all the queued values in each state union territory, and we sort the values by deaths. So we have the highest number of deaths in Maharashtra. Mean highest deaths. It's not the highest death of a day or something. The mean of death is highest in Maharashtra, and it gradually decreases. So that's what this sort value does. It sorts it, and the state union territory dot mean is used to find the mean values of each individual states. So if we can use max, okay. So we have maximum of 14,463 deaths in Maharashtra. So again, it comes to the top. So this is very useful when you are trying to know the maximum or minimum of data. So I think group by is very handy to actually look at how your data is, the maximum limits and minimum limits of data, and you can also group them to another data frame. Here I'm going to show you a example. So this str contains and capital T. This means wherever a state union territory contains a string starting or ending with T, just show me that. So if my strings are starting with capital T, Telangana, Tamil Nadu, Tirupura, all this state union territory will be shown. You can also make this into a data frame. Let's say it is going to be tdf equal to, and then you can play with this data frame. So this is a handy tool to split your data frame into sub data frame and then work on sub data frame. use something like this to get a data frame that has more than 0 lets. You don't want a you don't want the data that is having 0 lets. You want to look into data that has only lets greater than 0. This can be very useful for cleaning the data. So in this we have cured equal to 0, but you see the depth is starting from 1. You can also specify something like this. You want the depths to be greater than 0 and also cured to be greater than 0. Now we have at least one cured and one death in a day. So the data is changed like this. It is not changed, we are not saving the data. So we are just looking into the data which has death greater than 0 and cured also greater than 0. And let's see what data type this is. So this is df.datatypes. If you run this, we can see that yes number is an int 64, date is an object, and time is also an object, and cured again, death and confirmed, these three are again integers. But confirmed Indian national, this is an object because as I said, this data is not perfect. So after this we can go ahead and talk about how you can work with missing data. So df.drop_na, this will get rid of all the data that is having a null character. If you have, let's say if you are having a data in which a time is not there, it is going to drop that entire data. It's going to delete the entire row like this on the x-axis. So running this won't change our data because we don't have any null character in our data. The null characters have been filled with this negative string sign, negative string, so nothing happens here. And then we can also use a drop na, and then we can specify the axis. If you specify the axis to 0, then it is going to drop on x-axis, and you can set the threshold. If there are two data missing in a specific row, then you have to delete the axis. So now you will have some missing data. You will have one. If there is one missing data, it won't make a change. So this is something handy when working with machine learning. So this right here will fill the empty string into wherever it finds a null character, wherever there is no data. And if you want to do better pre-processing, if you don't want to lose data, you can do something like this. So we are taking df.cured, okay, and we are going to fill the null character. The value what we are going to fill it with is, we will fill it up with mean of cured, and we'll save it into df cured. So I'll go through this again. We are taking a data frame, we are taking cured, this thing right here. We are going to fill all the null characters. So if this cured is having a blank space, there is no element, there is no string, there is nothing, there is no object in it, it is a null character. If it is having a blank space, we are going to fill a value inside it, and that value is mean of cured. It is going to be mean of all these elements, all the cures. This will be more clear when working with machine learning, when we are going to actually work with null characters. That time will be more clear on how to deal with missing data and how you can pre-process the data better. So for now, I'm just going to give you the brief introduction to Pandas. We don't want time also. I'll load in the data again. We are going to drop the time also. What error are we having? Yeah, you shouldn't make any spelling mistake here. The directory should be exactly the same way. I do not want time. It's basically all 6 p.m., 8 p.m. and just a couple of other times. We can go ahead and take a look at our data frame. And this is our data frame now. We don't have time, we don't have confirmed Indian national, confirmed foreign national. We have pretty simple data now. We can create a new data right here. We can say that confirm df active, so we can take the number of we can find the number of active cases. So the number of active cases will be confirmed minus queued minus the deaths. Now you can see a new column appear right here named active. So now you have number of active cases. You can remove the head to see more data. So we have number of active cases. So this is how you can make a new data out of already existing data. This active is very important, very useful to know how many active people are there in your states and whether it is safe to go outside. Let's go ahead and take a look into our data by using df.info. You can see that the date right here is an object. So how do we convert a date into a uh, date structure? You want computer to know that this is a date. You don't want it to know that it's a object, it's a string. So here in Pandas we have a very useful tool called toDateTime, and it will convert all the string date. All this date right here is represented as string right now. Since it is in CSV format, we are going to use toDateTime to convert it into a date format. If I hit shift enter here, you can see that it has been converted to a date time 64 format. Now if you want to sort everything by date time, it is going to work. Let's get inside Matplotlib and I'll come back to this data again one more time. Let's start Matplotlib in a new page, in a new notebook file. Here I have opened my file and then I have also connected, and we are going to be using iris dataset, and I will also import my COVID-19 dataset inside this files. As soon as it gets in here, you can go ahead and to import the data frame inside this. You can type import pandas as pd import matplotlib.py plot as plt, import Seaborn as SNS. So you'll see why we prefer Seaborn more than Matplotlib, and Seaborn is actually a library built on top of Matplotlib. So let's go ahead and import these libraries. We have imported these libraries. You can go ahead and type uh, SNS dot underscore underscore version to know which version of Seaborn you have. It is on currently 0.10 on 0.1. Let's go ahead and get a data frame. Df equal to, let's go ahead and make a simple x equal to np dot we have to specify the start point, the end point, and the step 0.5. So now we have created x. Let's just see how x looks like. I would have covered this on my Numpy course. If you haven't seen it, you can go ahead and take a look at it. Numpy as np. If you run this now, you can see that we have an array from 0 to 4.5 arranged in the increments of 0.5. Let's create another array which takes x and it is going to modify x to make a curve. So we have x cube minus 3 x square. So this is an equation. This applies to all the elements in this. So if you go ahead and print x and if you print y, you will get an understanding of how this works. X is not defined. There we go. So we have 0, 0.5, 1, 1.5, and then we also have y, which is equal to x cube minus 3x square, and it gives something like this. So let's go and see how we can use Matplotlib to plot these datas in a chart. So we can type plt.figure. We can set the fixed size. You have to make sure that you give this fixed size inside curved brackets 12,8. Now we can see that we have created our figure size. Let's go ahead and plot the x and y. We need x, we need y, and we should be good. So we have a curve like this. If you guys cannot see the numbers here, I'll go ahead and change the theme back to light. Now you can see that it is a beautiful chart. It is plotting the x and y values with respect to their axis. Let's go and improvise this. We don't need this piece of code. This is to make the image larger. So even without this, it should run pretty good, but it's much smaller. That is why we have that in this place. So I'll go ahead and copy it back. Okay, that's good. Now we can also specify what color of line we need. If I change it to red, it gives me a red line. We can also increase or decrease the DPI as follows. We can set the DPI equal to 100, DPI equal to 300, or DPI equal to 600. But if you increase the DPI, it will take longer to process. But you will have a much cleaner chart. So if I give double dash, it is going to give me dotted lines. If you want green, you can go ahead and type G. It's going to give us green lines, and we can set the marker equal to, we need star markers. This should, yeah. So now we have star markers. We can set marker size equal to, let's say we need a huge marker size, so we have stars here, it's increased by a great amount. We can also set the line width equal to 2, so the lines are also thicker now. We can also go for 8. Now you can see that it's a huge thick line. So this is how you can plot your data on Matplotlib. You do have a lot of other features. You have something like let's see what all we have. We have fixed size, DPI, face color. So now we don't have any face color, we don't have edge color. Let me go ahead and type face color equal to white. Let me show red first. Red. See the borders, the face color has been changed. So if you're using dark theme and you couldn't see anything before, now you can see them properly. You can also make the face color white on a dark theme notebook to plot something like this. Let's jump to a more complex plot. We can go ahead and plot two data on top of one another. Here we create x, we create y, and we create z, and then we have, as usual, we have the fixed size, and we can also uh, change the face color to white, and then we have plt.plot, and then here you can see that we are plotting x with respect to minus y, and we are plotting x with respect to z, and we are giving a title, our first graph, and then we are labeling our x and y axis, and we are going to use this plt.legend to actually show the label. If you don't have this, the labels won't show up, and we are going to use plt.show. So let me run this, give you an idea of how it looks like. Okay, so we have a pretty big chart. I can reduce the DPI a little bit to make the image smaller. There we go. So this is our chart. So we have a red dotted line that represents x-axis and x values and minus y values. We have x and z values. So z is a negative value, so it's going constantly down, and it is a straight line. And then we have given a title, our first graph, right here. We are also showing that this is y-axis and this is x-axis. So we have given our x label and y label. If you don't give this x legend, if you don't give the x legend, it is not going to show you a label here. If you type in x legend, if you type in legend, plt.legend, so you can see we have a label z line. You can also label the x line or the y line. So we can call this as y line. So if you don't have legend, these won't show up. That's why we use legend. If you don't have show, it is going to give you an address of where it is stored. So we just type plt.show to keep things clean. Now you don't see the address. So that's what those two lines mean. And we can use plt.xtics So here you can see guys, it is starting from 0 and the number ends at 4, but we have 5 values. We can go ahead and type it for ourselves like 1 2 3 4 5, and then if you run it, we'll have 5 till 5. I think that's it about simple plots. Let's go ahead to bar plots. There's a lot of plots. You can look into the documentation if you guys want to see different types of plots, and if you're interested to use some other plots. So here I'm going to create a simple bar plot. Let's say 1.1.8 comma 2.3 comma 2. Plt dot bar values, and if you run this, we get a simple bar plot. You can customize this as much as you want. You can add in hatch, you can add colors, you can do a lot of stuff. But let's go ahead and jump into the next topic. Right next, we'll actually import a data frame. We'll first import the data frame that we already played with. We'll import this India COVID-19 India.csv data frame. So here we have the data frame. We can simply use the same methods, same Matplotlib library to get a chart like this. So we have a number of death, number of cured, and number of confirmed cases in the chart. We can also specify the face color for this. There we go. And then we can, yeah, if you guys are wondering what is this df.date, you can simply convert this or interpret into this is what we learned in pandas before. So it is as same as dot, using dot date or dot confirmed. So let's jump into Seaborn. Seaborn is actually much simpler and makes your life much more easier. Let's go and import Seaborn. I have already imported Seaborn up top, but if you guys haven't imported Seaborn yet, you can go ahead and import Seaborn. So Seaborn is basically built on top of Matplotlib. So eh, things like plot.figure and access, these things should work the same way. You can customize the DPI face color to white, and we are going to simply in Seaborn. One really good thing about Seaborn is you can tell what you want X data to be, what you want Y to be, and you can say that you want the data to be you want these things, the date and cure, to be taken from data. You don't have to type df dot date, df bracket and then date. You don't want to type df dot cure. You just have to specify them and then you can tell from which data it has to extract. And for simplicity, let me just remove this and show you guys how the plot comes. It comes with an error. I think this is the problem. Yep. So here we have a graph showing the number of queued visit date, and then I can go ahead and add hue equal to state. Data quantity of hue could not interrupt the input state. Yep, we need to type state union territory. Now we should be good. There you go guys. So you can see that the different states are indicated by different colors, but we have so many states, so all colors tends to be really similar. Let's go ahead and plot some simpler data set. Let's go ahead and use iris dataset. So I'm going to redefine my df to have iris.csv. Let's check out how it looks like. So we have id, we have the species name, we have sepal length, sepal width, petal length, and petal width in all in centimeters, and we have three different species in iris dataset. This is a very good dataset for beginners for learning machine learning. It's widely used to teach these pandas, matplotlib, and used in machine learning. So let's go ahead and see how we can plot everything in a iris dataset. Let's go ahead and pair plot. We use this all the time in machine learning. It takes a while, it's a big chart, it gives you everything you need. So here you can see that we have id, we have sepal length, we have sepal width, petal length, and petal width. We have basically everything. And we will see with respect to petal width, we have id. With respect to petal width, we have sepal length. Similar, basically you have everything. You can see how these data corresponds to one another. And if you see this, it's not going to give you any idea about what species this is. So that's what a machine learning program would have to do. So we can see the different species by using hue. So what hue does is it gives different colors to different species. We have three different species and it gives three colors. And the spelling should be exactly right. Even the capital should be correct. If you miss the capital S, it's going to throw an error. So here you can see that petal length is very low for very small for iris setosa, and you can see how each data correspond with one another, how each species is different from one another each. And let's see here, we have sepal length and we have sepal width. So this right here we can see that iris versicolor and iris virginica, they both are similar when it comes to sepal length. So a machine learning algorithm will find this very difficult to it will find it very difficult to classify whether it is iris virginica or iris versicolor. So you can correlate between different datas. You can also type df.corr. Let's go ahead and see how it matches up with what we have. So this plot just correlates all the data. This is also df.corr. We can see that sepal length and what else? Sepal length and petal length, they correspond closely to one another. So what this means is it gives you a value between -1 and 1, and if it is 0, there is no relationship between uh, let's say if there is no relationship between sepal length and something like sepal width. Okay, so if they correspond with one another, it's going to give you a positive value, and it is going to be somewhat like 0.8. So we can see that petal length centimeter and sepal length centimeter have a very good relationship. So these are the things that a machine learning algorithm will understand easily. And we can also see that petal width and sepal length correspond with one another very well. So these negative values, they are going to show that they are not related to each other, and that they are opposite to one another. So this is going to be numerical. If we plotted something like this, it is going to give you a much better idea of what individual components look like. We can go ahead and also make a heat map out of it. So using this same df.core, we are making a heat map. So what is basically a heat map? A heat map will generate an image like this that gives value between -4 and 1, since -4 is the greatest minimum value of this correlated value. So we are having -4 here and 1, and it is going to give different color for each of these boxes. So rather than just seeing the numbers, you can represent them as different colors. You can also type a not equal to true, and it will give you the numbers also now. And if you don't like these colors, if you want something vibrant or something, you can always change the color by using cmap. You can see all the colors available in the see. We are changing from yellow to green to blue. So YL yellow to GN green to BU blue. I think that's how it works. We can say dark. It's a color map, so you can go to Matplotlib, color maps, and here you can see all the color maps available in Matplotlib. So you can go ahead and copy any one of these color lab, and let's go ahead and choose terrain, TRRAIN. And we have a different color map. So that's how you can change the color of the heat map. And we are coming to a point where it's going to be very useful. We use this all the time. This is called scatter plot. Now to simplify things again, I'm going to get rid of, let's just get rid of this. So we have our data. The data is df. We want x to be id. We want sepal length to be centimeters. So we can see that our first 50 data is actually Iris setosa, and the sepal length is pretty small for them. For the next category of species, we have higher sepal length, and for Iris virginica, we have we have plants with very long sepals, and we also have plants with very small sepals. So this is how a scatter plot looks like. We can go ahead and add something like this. Now this size, it determines the radius of each of this dot, how thick this dot should be. So I'm going to say that give me petal width centimeter. If we have a bigger petal width centimeter, it is going to be more bigger dots, and if the petal width centimeter is smaller, then it is going to be a much smaller tiny dot. And we are going to change the color theme, so we use palette here, and we are going to use dark to theme. So as I told you, we have so many color maps here. You can go ahead and play with all the different color maps. Let's go ahead and run this and see how this looks like. Right away we can see that petal width centimeter for Iris setosa is pretty small. These dots are so tiny. So here you can see that Iris setosa, they are having smaller dots, which means they have smaller petal width. So maybe the petal width is more important than sepal length centimeter. And we can see that Iris versicolor, it's having a slightly bigger petal width, and Iris virginica is having thicker petals. They are having wide petals. These things will make much more sense when you are actually going to use this for machine learning, but right away if you are interested in presentation and all, you can go ahead and use these kinds of plots, and you can save these plots also. Let's go ahead and make count plot. I want to count the number of species, how many so I have 50 Iris setosa, 50 Iris versicolor species, 50 Iris virginica. Let's go ahead and take a look at our data again. We can make box plot, bar plot. Let me go ahead and type this. So this is basically a bar plot. I don't need this axis. Let's get rid of this. We need data to be df, x is id, y is sepal length centimeter, hue is species. Yep, there we go. We have a beautiful bar plot now, and we can actually make more bar plots. We can plot multiple plots at a time. You have to fit axis. You have to type fig comma axis equal to subplots and specify 1 comma 3. So number of rows and number of columns you want, how many. So we are going to give 1 comma 3, that means we are going to have single row and 3 columns. That gives us three plots to work with, and then we can type specify the fixed size. I want it pretty large. I want it 8 comma 7, and then we have to equal to true. We can go ahead and fig dot subplots super title. So this is subtitle. This will give a main heading. data visualization. We can go ahead and plot three different bar plots now. So here we have sns.bar plot. We are specifying the axis. We want it to be the first. We want it to plot on the first axis. Let's go ahead and remove this. Let's just plot the axis first. So we have three axes now, and we are going to draw on individual axis. First, we are going to make a bar plot that contains id and sepal length. Then exactly same thing, but we are going to change y to petal length, and then we are going to change y to sepal width, and then we are specifying the axis. So ax equal to axis 0 1 2, and this is going to set title. What title you want for the axis you are working on. So if you want to set axis to a title, you can do this by using this line of command. Let's see how this comes out. Okay guys, so you can see the petal length, sepal length and sepal width. We have given a main heading called data visualization. We have id, they are merged together. We can also type dot title layout to make things much. So if you see these numbers are not coming properly, you can try this plt.tight underscore layout. I want this to be 14. So this is how you can plot like many plots all in once. Oh god, this is pretty long plot. Let's go ahead and go for a different plot also. Let's just see the output of this. So you can go and play around with all the parameters and see the result for yourself. So you can see that petal length actually plays a very important role in deciding which species it belongs to. Let's go ahead and plot 4 plots. Now we can see all the 4 data with respect to one another. We have sepal length, sepal width, sepal, and then we have petal width centimeter, petal length centimeter. So this is all done in like one block of code. So you can go around and play with different subplots. We have 2,2 subplots, which means we have 2 rows and 2 columns, and then you can specify the axis by uh, typing axis bracket 0 comma 0 and 0 comma 1 and then 1 comma. You are specifying the row and column, which row and column you want this data to be plotted on, and you can plot diagrams like this. You can go ahead and also plot histograms. So let me tell you what a histogram is. A diagram consisting of rectangles whose area is proportional to the frequency of variable and whose width is equal to the class interval. If this doesn't make any sense to you, thanks to dictionary. It is a similar, I'll make things simple. It is similar to a bar chart, but a histogram groups numbers into ranges. The height of each bar shows how many fall into each range. I'll just copy this and paste it right over here. Let's go and plot a histogram. It's going to be huge. I've set the DPI to be 600. It's probably a mistake. Yeah, here we go. Yep, here we have a histogram. So we can see, okay, this histogram is defined by distplot, sns.distplot, and then we are specifying that sepal width is the parameter that we want to plot in our distplot. What this plot does is it takes all the elements within this range from 3.0 to 3.1, and then it counts how many number of times we have a species or an ID fall into this group, and then it's going to plot a bar plot like this. So we can see that we have a lot of plants belonging to 3.0 to 3.1. That's what this plot shows. Basically you can use this to filter the data. If you have too many data on a specific place, you can then get rid of those data, so your machine learning algorithm understands that it just basically treats all data as equal, so you are not giving importance to certain parts of the data. So this is pretty handy tool. I always use histogram and scatterplot. We can go ahead and use box plot. A box plot, it gives you 5 things. A box plot contains, let's go ahead and plot it, and then I'll tell you what all we can see here. We can't see anything because the figure size is pretty tiny. Let's go ahead and do this. It's gonna be insanely huge. There we go. So a box plot contains a maximum, a minimum, a median, or you can say that yeah, it's median to be precise. A median, and then 25% and 50%, 75%. So in this we can see that let's see something right over here. We can see that 20 is the median, 2.98ish sepal width. In 2.9ish sepal width, most of the plants belong to an ID of 20. You get the point, right? And this is the maximum that a plant has gone. The minimum ID that a plant has got belonging to something like 2.98, and when the sepal width is 2.98ish, this is the this place for around 50ish ID is the maximum it has got. But most of the most of the species, most of the ID falls at 22-ish range. So that's what this gives. This gives the median 25%, 75%, and minimum maximum. So you can get pretty good results from, you can learn a lot of things by using box plot. When you're working with large data set, you can see that uh, you can see basically where most of your data lies, and some things like these dots, these lines, these are just unwanted noisy data. Most cases you don't need those data to train your neural network, to minimize the training time and also to optimize the program. So if you're having like just the 25% to 75% of these data, it's more than enough, because that's where most of the data is. That's the most important data. This top and this bottom, the minimum and maximum, those are rare cases. So out of 100 species, only 1 or 2 species might lie in this point, in this maximum and minimum points. This would make much better sense when you are working with larger data set and data set that makes sense actually. So let's go ahead and finish off this course with joint plot. So SNS dot joint plot, and then we can call in petal length, sepal width. This gives you both a scatter plot and histogram at the same time. So you can see this is the scatter plot kind of thing. This is the histogram showing how many data, how much of data lies at this place. So I think that's it about Seaborn and Matplotlib. Let me go ahead and show you guys some more links and some more things that you might need to know. So we have count plot, we have marginal histogram, we have a lot of things in Matplotlib. So you can, with a simple Google search, you will find a lot of link to get an example code and also to see how things looks like. So we have distribution plot, and we have many different types of distribution plots. We can go ahead to Seaborn. So these two I showed you. These things belong to Matplotlib. We are going to Seaborn, and you can see it contains not just one or two, it contains many plots. So you can just come to this website seabornpydata.org, or you can simply type Seaborn different plots in a Google search. You will get this as the first page. You can go ahead and click bar plot, and it will give you an example, and you can start working your way around to fit your data. And these are scatter plots. You can use this code and modify this code for your data set. This is another box plot. So I highly recommend you to check this page out and see things for yourself. So this is an heat map, and as I told you, these are the color maps that are available in Matplotlib and Seaborn. I think that's it for the Matplotlib and Seaborn guide, guys. See you on my next video. By the way, all the notebooks that I taught here will be posted on my GitHub page. You guys can go to my GitHub page and download my notebook and try these for yourself. You can run these programs and try it for yourself. Thank you for watching my video. Please click the like button if you like the video. Please hit the subscribe button if you want to see more. I'll be making a lot of videos in the upcoming days. See you guys later. Bye.